Hello guys, welcome. We're going to be discussing graphing sine and cosine, the graphs of sine, cosine. They're also referred to as the sinusoidal functions. I don't emphasize the term that much. We'll talk about it some more later on. But let's go ahead and get started. Some preliminary work before we go on to graphing these particular functions, guys, okay? Now, at some point last week, I think I recall giving you guys a chart, something similar to this, with some basic information about some of these degree measures, their radical measures, and the corresponding sine, cosine, tangent values, okay? So I'm just to recap, I'm gonna go ahead and give you that information again, since we are going to be using this information right here to get through the graph of sine and cosine. And later on, we'll do tangent too, okay? So guys, here we go. So for this one right here, we're gonna start off with the degree measure. At 0 degrees, which is the same thing as 360 degrees, the radian measure, of course, is 0. So sine of 0, remember this is along the positive side of the x-axis, sine of 0 is 0. There's no vertical change, okay? Cosine of 0, though, is 1. And tangent is the ratio of sine over cosine. Tangent would be 0. Now, we're going to move on to the next quadrant. In this case, pi over 2. Actually, let's do 90 first for the degree measure. The radian measure would be pi over 2. Sine of pi over 2, because we're moving vertically, all right, would be 1. Cosine would be 0, so the tangent would be undefined. Undefined. Next, we're gonna go around to a half a circle, semicircle, 180 degrees, which is pi. At pi, we're on the negative side of the x-axis, so sine is 0, cosine is -1, and tangent is 0 as well. All right, and then last but not least, okay, we're gonna go to 270 degrees. At 270 degrees, we're looking at 3 pi over 2, as in pi plus pi over 2. The sine would be a -1, the cosine would be 0, so then tangent would be undefined. Now, we need this information, guys, seriously, to be able to graph these functions. It helps to have this basic knowledge. All right, so here comes the starting point, guys, with graphing sine and cosine. The sine function, sine x, or as a function, you can write it as f of x equals to sine x, okay? Basic information about the sine function. The domain, that's your x values, guys. There's no restrictions on the domain. It's from -infinity to +infinity. The range, however, okay, goes from -1 to +1. It oscillates between -1 and +1. The period, or one cycle, of the sine function is approximately 2 pi. The period, or one cycle, one full cycle, and then it starts repeating every 2 pi. You see the same shape, the same figure, the same format, okay? It happens every 2 pi, guys. So it's a repetitive function, basically. So this is an odd function. What does it mean to be an odd function? It means that if we were to plug in a negative value into the sine function, the corresponding output would be a negative sine value, a negative answer, or the opposite of sine. So let's say we do sine of pi over 2. Sine of pi over 2 is 1. But if you do sine of negative pi over 2, that's going to give you a -1. You see the opposite in there? Okay. All right. So it's an odd function, guys. Now, when we're dealing with the sine function, f of x equals to a times sine x, the leading coefficient being a, that a value, guys, represents the amplitude. Amplitude. Oh, I think I'm misspelling that right there. Amplitude. Now, what in the heck is an amplitude? Think of it as a range or a magnitude, guys. Here, let me write this down for you. A range or a magnitude, okay? Now, the amplitude is very, very important with these graphs, guys, okay? So I'm going to erase this. So if f of x is equal to a sine x, all right, and a is the amplitude, the absolute value of a, that is, okay, because you have to look at the positive of it. Now that a value, the amplitude, determines whether the graph is going to stretch or shrink vertically. Now, when a graph stretches vertically, it gets thinner, it gets closer and closer to the y-axis, but when it's shrinking, it gets wider and wider, and it gets closer and closer to the x-axis. So here's the bottom line, guys. If the absolute value of a, let me use capital A here, is greater than 1, the graph is going to stretch vertically. However, if the absolute value of a is less than 1 but greater than 0, the graph is going to shrink vertically. You should remember these guys from the transformations. We talked about these, actually not in my class, but we talked about transformations in some of your previous classes, okay? So guys, now that we have all this basic information, additionally, before we start graphing and the how-to of graphing these functions, okay, I am going to go through this basic chart with you. I'm going to go through a basic chart with you about some basic values you need to be aware of, guys, when it comes to the sine, okay, y equals to sine x. So I'm going to start off with 0. If we do sine of 0 is going to be 0. I'm just going to go around the entire unit circle, guys. Pi over 6, which is the same thing as 30 degrees. That's going to give us 1/2. We're in the first quadrant, by the way. Pi over 3, that's equivalent to 60 degrees. So that's going to give us radical 3 over 2 when you take the sine of pi over 3. Next, we move on to pi over 2. That's the 90 degrees right there, guys. So that's going to give us positive 1. And then we're going to repeat it. Now we're in the second quadrant. Once we get into the second quadrant, we're looking at 2 pi over 3. And 2 pi over 3 is going to be radical 3 over 2. And then you move on to 5 pi over 6. 5 pi over 6. That's going to give you 1/2. And of course, you're leading to pi. And when you get to pi, you're going to end up with 0. Now, remember the sine function has a period of 2 pi, guys. Right now, we're at pi. We're only halfway through that period. For us to have a full, okay, period, you have to get to 2 pi. We're at pi right now, okay? So let's keep going. Now, after pi, we move on to 7 pi over 6, which takes us into the third quadrant, okay? At 7 pi over 6, now we're looking at negative y values. So this is going to be a negative 1/2. And then you move on to 4 pi over 3. Now 4 pi over 3 is going to be a negative as well because we're still in the third quadrant. Next, we have 3 pi over 2. Remember that from earlier? 3 pi over 2. Sine is at negative 1. And then, guys, we're finally on the home stretch where we get to the fourth quadrant and y is still a negative. So you've got 5 pi over 3, which gives you negative radical 3 over 2. And then you've got 11 pi over 6, which gives you a negative 1/2. And then finally, we're up to 2 pi. And at 2 pi, you know what happens. Pretty much you're starting all over again, okay? So guys, we needed to get these out of the way because this is going to help us later on. So now let's talk about graphing. How do we graph, okay, the sine function? So to graph the sine function, guys, here are a couple of steps. To graph the sine function, number 1, find the amplitude. Find the amplitude. Now the amplitude is going to help you with the range. okay, where the graph vacillates between on the vertical axis. So find the amplitude, and that's going to help you with your range, guys. And the period, okay? Now, for now, I'm just giving you some basic information. Just know that the period is going to be 2 pi, okay? Number 2, we're going to find the x-intercept, the x-intercepts, because there's 3 of them, okay? The max value in that 2 pi period and the min value in that 2 pi period. By the way, the max and the min has to do with the amplitude all over again. And we'll talk about that in a minute, okay? Now, number 3, we're going to go ahead and find key points on the graph. Find key points on the graph. Now, normally they might tell you to find 5 key points, okay? For example, they want you to start with the initial value being x equals to 0, and then you break up the full period into 4 parts and just keep adding pi over 2, guys, until you get all those points. And I'll mention it to you in a little bit, okay? So find some key points, and then you want to go ahead and plot the points and sketch the graph, okay? I'm keeping it very basic, guys. Very, very basic. Sketch the graph, okay? Very basics. I mean, very basic, Shazam, okay? Now, whatever you don't get here, guys, we'll talk about it some more when we get into the classroom. So guys, here we are. Let's go ahead and look at a specific example, because sometimes it's with the examples that you really truly learn what's going on with these functions. Y equals to sine x. It's 2 sine x, okay? 2 sine x. All right, guys. So first, the amplitude, the coefficient of sine x is 2. So the amplitude for this one is 2. Now, this also helps us to determine the range. So the range is going to be -2 to +2. This is also going to give us the max and the min value. The max would be at -2, and the min will be at +2, okay? So once again, guys, the max, the graph is going to reach its max at -2, its min at +2. Oh, Shazam, what did I just say? That doesn't make any sense. The max at +2 and the min at -2, okay? We got to rectify that, okay? I'm trying to write 2 here, guys. For some reason, it's not writing. Okay, let's try that one more time. -2. There we go. There's our min, okay? So, guys, in order to be able to graph this one right here, okay, we are going to go ahead and go to a chart. We're going to create a t-table, all right? Now, when we're creating this t-table, I want you to think about just the basic x values, okay? By the way, guys, the horizontal axis consists of the gradient measures, and the vertical axis obviously would include the range. So I'm going to go to a tree chart here, and you know, let's go back a little bit here. I am going to erase this and put sine x instead, sine x, okay? So we're going to start off with 0. If we plug in 0, we're going to get 0, because sine of 0 is 0. Now let's say we plug in pi over 2, guys. Now pi over 2, listen to this, is 90 degrees. What is sine of 90 degrees? 1. Then you want to go to pi, which would be 0. Then 3 pi over 2, which would give you a -1. And then 2 pi, and that would give you 0, guys. Okay? But this is your basic function. This one right here, you have a 2 in here. Okay? There's a 2 coefficient. So what is going to be affected? Right here, guys. The 1 and the -1. So right here, this is going to be a +2 instead, because sine of 90 degrees is +1. 1 times 2 is 2. Same thing, sine of 270 degrees, sine of 3 pi over 2 is a -1. -1 times 2 gives you a -2. Okay? So do you see the changes? All right. So guys, we're gonna go ahead and go to the XY plane. Let me undo this one right here and bring it closer to here, okay? So I am going to sketch out my graph, all right? So when I sketch out my graph, I'm gonna be very deliberate with this, guys, okay? Because remember, I highlighted some key elements in here. Now, I've got my pi over 2. Here's my pi in the middle over here. Okay, maybe I should have just graphed a little bit more than that, okay? So let's go ahead and take some of this out. Let's put the pi over 2 right here, okay? And then we're gonna put 3 pi over 2 over here, okay? And then we're going to go ahead and put the 2 pi over here, okay? So we're gonna go ahead and graph this. Now here's our vertical axis. Remember guys, this has a range of +2 to -2, or if you're writing it in interval notation, it would be from -2 up to +2 in numerical order. So at 0, the graph is still at 0, okay? When x is 0, the graph is still at 0. When the graph is at, when x is pi over 2, the graph is located at +2 right there, okay? I should try and erase this over here. Oh, yay, I got it. Okay, awesome. Okay, you know what? Let me use a different color, guys, because that's going to make it look even better, okay? So pi over 2 is 2, maybe just slightly lower, okay? And then at pi, we're at 0, back to the x-axis. At 3 pi over 2, we're at -2, below the x-axis. And then at 2 pi, we're back at 0. So this will complete a full period, a full cycle of the sine graph. So guys, here it is. This is what the graph looks like. Whoops, I'm going up too far, okay? Let me go ahead and do this and just erase this. Just, oh, Shazam. I didn't mean to erase the whole thing. I'm just erasing a little bit of it. Can I just do it? No, I can't do a little bit of it. Okay, so we'll just leave it alone. Okay, guys? So this is indicating a full cycle or a full period of the graph, okay? So guys, right here, we've graphed the sine graph, okay? Now remember, this one had an amplitude of 2, so that's why it's stretched out like that. So, you know, the question will come up, well, what if there's a negative here, guys? What if it was y equals to a -2x, -2 times sine x? How would this change? How would it affect the graph of this? By the way, we're going to be going to cosine very soon. Okay, how would it change? What would change about this graph if it was -2 sine x? Okay, so guys, once again, this is where the transformations come in, okay? So that negative leading coefficient is essentially reflecting the graph over the x-axis. So pretty much all the 0 values remain the same, but the +2 and -2 will switch. So let me go ahead and do a quick table for you guys over here if it's a negative. So once again, we're still going to do 0, pi over 2, pi, 3 pi over 2, and then 2 pi, okay? We're still going to do the same thing. So at 0, the graph is still at 0. Pi over 2, it's now going to be a -2. And then pi, it's still going to be 0. 3 pi over 2, it's going to be a +2 this time. And 2 pi will be at 0. So guys, when you graph -2 sine of x, you're still starting at the origin, okay? At pi over 2, the graph is located at -2, right there, okay? And then at pi, the graph is located at 0. You see that? And then at 3 pi over 2, it's located at +2, right there. And then at 2 pi, it's going to be back at 0. Guys, here's the negative sine over 2 graph, okay? So guys, look at that, okay? So the graph just reflected, it reflects over the x-axis. That's all. That's what that negative did. It reflects the graph over the x-axis, okay? And just like that, we're done with the sine graph. Now, obviously, guys, the cosine graph is not too far behind. So let's go ahead and quickly figure out some information about the cosine graph, okay? So we're going to start off with y equals to cosine x, or f of x is equal to cosine x. And so just like with the sine function, the domain of this, the domain has no restrictions, negative infinity, positive infinity. There's no restriction. Remember, it's a repetitive function over the interval 2 pi. And then the range goes from -1 to +1. Okay? So it's oscillating between -1, +1. The period or one full cycle is 2 pi, just like with sine. And in other words, it's repeating every 2 pi, okay? Now, guys, on the other hand, the sine function, it's an even function. What does that mean if it's an even function? If we plug in, well, we're talking about cosine. Cosine of -x will give us the same value, okay? So you'll get a positive cosine x. So cosine of -x gives you the same value as cosine of x. Okay, so let's go ahead and take an example. Okay, so cosine of what's a good value? Okay, cosine of 0. Okay, that's +1. And then if you do cosine of what's another one? -1. I don't know. I mean pi. Okay. When you do these problems, guys, you have to make sure, okay, when you carry out these numbers here, you have to get the exact same value. So be careful with that one. I think that wasn't a really good one, guys. So let me try something else, okay? Let's try, okay, cosine of, let's pick one from here. Pi over 3, that's 1/2. And then if you go to cosine of -pi over 3, that will also give you a positive 1/2. So you see how, because pi over 3 is in the first quadrant and -pi over 3 is in the fourth quadrant, they will both result in a positive x value. So guys, this one is going to be even, okay? So now, and I know why the other one didn't work, because that one, it doesn't reflect across the y-axis. We're talking about reflection with respect to the y-axis. It doesn't, how should I say this? Reflect over the x-axis. So, and hopefully I didn't get you guys confused there, okay? Once again, guys, you know what? Let me write it down for you. If you were to calculate cosine of pi over 3, guys, pi over 3, that's in quadrant number 1, cosine of pi over 3, that's 1/2. And if you do cosine of -pi over 3, they both give you the same answer, 1/2. That's what this is about, guys. Whereas if you do it with sine, you're going to get the opposite of the other number, okay? That's what being an even function is about. Okay, so now, listen, let me go ahead and share some of these basic values with you when it comes to cosine function, just like we did with the sine, okay? So I'm gonna go again to my little chart here, y equals to cosine x. And just like before, guys, we're gonna start with 0. If we start with 0, you take cosine of 0, that's 1. Okay, we're gonna go to pi over 6. Now pi over 6, cosine of pi over 6 in the first quadrant, that's radical 3 over 2. And we just finished talking about pi over 3, cosine of pi over 3. That's gonna give us 1/2. Now we're gonna go ahead and move on to cosine of pi over 2, 90 degrees. That's gonna give us 0. Be careful with that, guys. That's the vertical, all right? We're gonna rotate around to the second quadrant, 2 pi over 3. And 2 pi over 3, guys, is just repeating. Now you're in the second quadrant, and once you get to the second quadrant, what happens with the x values? They're negative, so this is gonna be a negative 1/2. Then you're gonna go ahead and go to 5 pi over 6, and 5 pi over 6 is still in the second quadrant, so that's gonna be a negative as well, square root of 3 over 2. And then, guys, when you get into pi, you're looking at a -1. Now, we're halfway through that period, through that cycle for cosine, okay? So now, guys, we're gonna go ahead and move to the second half of it. The second half of it, 7 pi over 6. Now, you are in the third quadrant, 7 pi over 6. At 7 pi over 6 in the third quadrant, remember x is still negative, so here you're at negative radical 3 over 2. And then we're going to move around to 4 pi over 3. Ooh, Shazam, what did I just write? Ooh, that's horrible. Okay. 4 pi over 3. Okay, it's still a negative, guys, negative 1/2. Okay, so now guys, we get to 270. 3 pi over 2 and 3 pi over 2 is going to drop us at 0. And now we're on the way home, on the home stretch. We are at 5 pi over 3. 5 pi over 3 is going to be a positive because you're in the fourth quadrant now, so that's going to be 1/2. And then if you do 11 pi over 6, 11 pi over 6 is going to give you radical 3 over 2. And then last but not least, 2 pi. And 2 pi, guys, will produce 0. Right back where you started, okay? So that's the chart for cosine, all right? Now, when we're doing this, guys, when we're graphing cosine, we're graphing it just like we graph the sine. You know, you find your amplitude or period. Find the x-intercept, maximum, minimum. By the way, I forgot to mention with the sine function, there are 3 x-intercepts in the period over 2 pi. Over 2 pi, there are 3 x-intercepts, 1 max, 1 min. Now, for the cosine, guys, okay, you need to be careful with this one right here because, again, we're talking about a different function. So when we go into the cosine function, guys, and we're trying to graph it, be careful with those values. And just like with the sine function, I am going to go ahead and do an example with you guys. Remember, we're using the same process that we use to figure out the sine function. Okay, guys? So let's go ahead and do this. For the sine function, the cosine function, okay? It looks like we're just going to have a minimum, okay? So I am going to go to the table again. Okay, hold on a second. This is not writing well. Okay, the table, create my little table here, guys. Okay, I'm going to start with 0 again. Now, when x is 0, oops, let me go ahead and rewrite this. No, let's leave the 0 there. And I'm just going to rewrite this. By the way, I didn't even give you a function, guys. So let's grab a function. Y is equal to 2 cosine x. And I want to do 2 cosine x because I want you to notice the difference between cosine x versus sine x, okay? So 2 times cosine x. Since we've already gone through all the preliminary stuff with the sine, this should be very easy. So cosine of 0 is 1. 1 times 2 is 2. Next, we're going to move on to pi over 2. At pi over 2, cosine of pi over 2 is 0. So 2 times 0 is just 0. Now we're going to move on to pi. Cosine of pi is going to be a negative 1. Negative 1 times 2 is going to be a negative 2. Now, guys, be careful, okay? 3 pi over 2. That's going to give us what? 0. And then 2 pi, that's going to give us what? Okay, that's going to give us another 2, guys. So that's the full period, the full cycle for cosine. So now, guys, we're going to go ahead and go to the XY plane, and we're going to graph this, okay? So this time I'm going to promise to do better, okay, guys? I'm going to do pi over 2 right here. I'm going to do pi right here, and then 3 pi over 2. Oh, yes, this is looking so much better. And then my 2 pi is going to be right here. And then 1, 2, 3, 1, negative 2, negative 3. All right, guys, let's graph this, okay? So here we go, guys. All right, 0, 2, right up here. When x is pi over 2, we're at 0. When x is pi, ooh, we're way down here at negative 2, guys. All right. Remember, the range of this graph goes from positive 2 to negative 2. So the highest it will be is positive 2. The lowest it will be on the graph, the lowest point on the graph is going to be at negative 2. So guys, let's look. At 3 pi over 2, we're at 0. And then at 2 pi, we are at 2. Shazam, look at this graph, guys. Look at this. There you go. There's your sine graph, guys. And notice right here, we have a minimum value at +2. Yeah, minimum value at +2. Now, effectively, what is going to happen, guys? This is going to, let me go ahead and erase some of that. Okay, there we go. This is going to get into this quadrant. For example, if we were to put a -π/2 over here, if we plug in a -π/2, guys, cosine of -π/2, we're on the negative side of the y-axis, okay? That's going to be 0. So, guys, this graph is going to turn. So, what do you notice? Right here, we're going to have a maximum value. But over that period, right here, okay, which is 2π, there's only one minimum. Ooh, that's not good. That's not good. Let me erase that. And let's dot it out, guys, over this period right here. Okay, that's 2π. That's the period for the graph. And over that period, there's only a minimum value at +2. Okay, so I wanted you to notice the difference between the sine and the cosine. Well, the other question you guys might be asking yourself is, how is this different with the negative leading coefficient? And just like before, guys, the graph would be reflected. Okay, so all of these, the signs would change. It would be reflected over the x-axis. So rather than having the minimum up here, we'd now have a maximum, and the majority of the graph would be in the top quadrant in quadrant 1. So essentially, guys, that's all I needed to discuss with you guys about graphing the sine and cosine function. There's more, okay? There's more, because we haven't talked about the horizontal stretching and shrinking. Oh, guys, by the way, you know what? Let me go ahead and drop these two problems right here. So if we have y equals to 2 sine x and the amplitude is 2, this will reflect a vertical stretching by a factor of 2. What if we had instead y equals to 0.3 sine, let's do cosine, okay? Let's do cosine. 0.3 times cosine x. Here, the amplitude would be 3. And so this one would be a vertical shrinking, okay? Vertical shrinking by a factor of 0.3. So guys, this graph would be wider than the first one. And so when you sketch this out, the 2 sine x is going to be closer to the y-axis, whereas the 0.3 cosine x would be closer. It would be wider. It would be getting closer and closer to the x-axis, okay? So it's trying to basically flatline to get to that line y equals to 0. So the smaller that leading coefficient, the closer it gets to the x-axis, which is y equals to 0. So effectively, guys, this is what I wanted to discuss with you guys, talking about the basics of graphing the sine and then the cosine function. There's more to it, okay? We haven't talked about the horizontal stretching and shrinking. Guys, there's more to this, so hang on. We're going to stop it here because I don't want to make it that long. So until next time, bye, everybody.